Hello, this is probability question homework 6. This is the first question. And this question is about to calculate the joint density function and to verify the x and y, the relationship between x and y. I have write it down and I want to explain the answer. The first question is about to find the a that make it a valid joint density function. You can see the original function is like this. And we know the x domain of y. So to make it valid, that means if we do the integral, the x and y, we can know the answer should be 1. So we do the integral x and y by this joint density function, and then we calculate. Finally, we find it's equals to 4a. So 4a should be 1, and a should be 1/4. So the second question is about to verify the x and y's relationship, to determine its x and y uncorrelated or not. So my answer is they are not uncorrelated. They are not correlated. They are not correlated because this is the reason. You can see, because we know a equals to 1/4, and we can get the complete joint density function, and we can find the fy, the density function, by integral the x. You know the x domain is from -1 to -1, so we can get the answer should be 0.5. And because you can see the joint density function, it's a symmetricity. I mean the x1, y can change to each other, and the answer is the same. So that means the f x y, x can be y, y can be x. So that means fx equals to x, fy equals to the same, 0.2, 0.5. So we can get the expected value of y by use this formula, and we get the answer should be 0. So ex is also 0. We know the expect value of x and y, xy. We should use this formula, x and y, and multiply the joint density function and do the integral, and finally we can find the answer is 1/9. So we can calculate the c equals to the expected value of x plus x minus x multiple y minus x ex multiple ey. The answer is 0 because it's not equals to it. The answer is 1/9 because it's not the 0. So they are not uncorrelated. And here, third question is about to depend it x and y are independent or not. So my answer is they are not independent, because we can see the joint density function cannot separate. I mean, joint density function is equals to this, but it's not equals to fx multiple x fy. it cannot separate. So that means they are not independent. The fourth question is to find the joint density function of x squared and y squared. So we define another joint density function by using z and w. We define z equals to x squared and w equals to y squared. So, and we find the x has 2 points in y has 2 points of w. So we can use a fundamental theorem. So we find the joint density function of z and w equals to here like this. And why we write this gx? How to write this? It is because we should find j. J is by using this is a matrix. So we should do the derivative like this, and then we find the answer and get the answer. So we write down the answer should be here. Why it is here? It is because actually we know we have 2 points of x and 2 points of y. That means there are 2 multiple 2. That means we have 4 combinations. So we have 4 points. So we find the 4 points. We write down these points and the minus points, minus the, and we know another 2 is the same as before. So I multiply 2. So answer is here like this. And I think it's a fifth question. The 5th question is to prove or disprove x squared and y squared are independent. So my answer is they are independent because we can find the density function fw by using integral of z by the joint density function zw, and we can find the answer. And you know the z domain of z should be 0 to 1, and we write down like this is the answer. And w is the same as z. Z is same as w, so this is the answer. So we should use the same formula to find if independent or not. Multiply these 2, we find the answer, but they are not. They are exactly equals to joint density function of w and z, so they are independent.